All right, hi everybody. Thanks for hanging with us till the end of day 2 of Cloud Next. And I'm Jeff, and we're going to talk about spanner search. And I bet a lot of you already use it. So raise your hand if you searched content in either Google Drive, Gmail, YouTube, or photos, say, in the last day. See? Last hour, okay. So congratulations, you already use spanner search. So spanner's the data platform that sits underneath just about all the Google products. And the search that we provide in Spanner, the search capability, is used by all these products as well. So that's what I mean when I say if you're searching in those products, you're actually using what we're going to talk about in this presentation. Also, we offer it to our Cloud Spanner customers. So for example, if you took an Uber this morning to get here, you also used spanner search. So that's why I claim that spanner is everywhere. Wait a minute, what happened? Different order. So this is why I claim spanner is everywhere. So I'm going to go back. So I'm Jeff. And we have Alexander from Attio, who's going to tell us about his great journey with spanner search at Attio. And then we have Girish, who's going to talk about a lot more details of spanner search. And there's the agenda. So I'm going to do a quick introduction. So first I want to talk about Spanner itself, though. So Spanner as a platform offers a lot of advantages for search workloads. Some of the key advantages are zero maintenance, near limitless scalability, and very high availability with a 5 nines best-in-class SLA. And it's also a multi-model platform, which is critical. What it allows you to do is not only use it as have a relational database, but use that same data to serve a search workload or maybe a graph workload without having different copies of data all in one platform. So now I'm going to talk about some typical search applications that people would run on Spanner or develop on Spanner and run. First would be e-commerce. So think about a product database where you're storing all your product info and you need to search it. You might need to search it using text, or you may actually use AI to understand the meaning of the data that's stored and then search based on context. Another example would be healthcare, where you're doing a patient or a provider search using the doctor's name or the provider's name, what have you. And in these cases where you're using search, we need to be able to do a fuzzy search as well, where you might have spelling differences or other issues. Let's see, then the next one is content management. The Google Drive example is in this category where you would want to search the content of documents using text, or you might want to use AI to understand the meaning of the content in the document and then search based on that. Or you might want to do a combination, actually merge the two techniques for different types of results. And then finally, I use services more as a generic category here, but we have a lot of customers who have a user database or a customer database, and they need to search names, first name, last name, address, phone number, what have you. And they need to be able to account for spelling mistakes, et cetera. So there's a lot of customers that have implemented that on Spanner. And traditionally, to implement a lot of these kinds of search workloads, you would have to run a whole separate platform. And Spanner allows you to do this all in one place. So these are the features of Spanner search. Full text search is the keyword search where you're going to search for words or combinations of words. And you want to use fuzzy search as well to find spelling variants or maybe synonyms that would match. Vector search allows you to use AI to, again, understand the meaning of your stored data, and then search based on the context of the query. And I have an example here, space Lego for 8+. That's a common thing. Like somebody might type that in searching for some kind of product, and vector search works very well for those kinds of those searches. And then hybrid search is where you merge the two, where you're combining search based on keywords or text with vector search to understand the meaning of the data, and you merge the results accordingly to have the best combination of results. And like I say on the slide, it's the best of both worlds. Now, I mentioned that to solve a lot of these search problems, today, or traditionally anyway, you had to run a whole separate platform. And the problem with that is it introduced all kinds of problems, especially in the case where the data originated from a database. You had to copy data to something else to search it. And you also have to worry, so you have to worry about ETL pipelines, duplicates, different copies of your data. Also, data lag is really important when it comes to search. You don't want to search stale data and have stale results just because it hasn't been copied over yet to the search system. So these are all different problems that Spanner can solve when you implement search on Spanner. And the same would go for graph. So here are the benefits of Spanner search. The last slide is a great lead in to the first point, which is reducing operational toil, eliminating data copies, eliminating ETL, keep your data in one place and be able to do everything with it. OLTP workload, search, et cetera. Performance and scalability. So Spanner, I mentioned earlier, has near limitless scalability. This is really important for search workloads. It's a common pain point that we hear about from our customers. And then finally, availability and reliability. I mentioned Spanner has best-in-class availability at 5 nines SLA. And I just had a customer this week. They wrote a blog about their journey implementing search on Spanner, and they said they're re-architecting search for planet scale. So that's a great example of availability and reliability benefits you get with Spanner. Okay, now the last thing I'm going to do is just a really quick demo. I just want to show you the differences in the results really quickly of the different search methods. So first would be full text. Oh, by the way, let me start over. I'm going to set this up a little more. So what we have is a product database, and we're going to use that same query, space Lego for 8+, that I showed earlier on that slide. And we're going to do the same search with all three techniques. So let's see if I can get this thing to play. Go back. There we go. Okay. So we're going to see the results in the bottom. And here you can see the space-themed Lego for 8+, and we got two results where we've matched the terms in the search input to the stored data, and we found two things. Now, the next one is vector search. This is where we're going to use AI to search based on the meaning of the data. And as you can see, we found more things. And you'll notice there's an age 4 to 7 in there, which doesn't quite match the 8+ at the bottom there, the third one. But still, we get more results, more contextual results. And then the last one is a hybrid, where we're going to pull the results from both, and we're going to merge them together. And you're going to see here that we'll get more results that match the original query by merging these together. So, and you can see here at the bottom, we're using a reciprocal rank fusion to actually rank the data where we get results from both. And there you go. So now they're all 8+, and you have a better quality result by using both. All right. So I'm going to hand it over to Alexander. He's going to tell us about all the great things Attio was able to do when they implemented both Spanner and Spanner Search.
Thank you very much, Jeff. Hello, everyone. It's great to be here at Google Cloud Next, and we're really excited to share a little bit about our experience building with Spanner. So for those of you who don't know, a quick introduction. Attio is the AI-native customer relationship management platform, and we power some of the fastest growing technology companies in the world today. Companies like Modal, Granola, Railway, and a few AI labs who prefer not to be named are building and growing on Attio. What we provide is a unified platform that's built for both humans and AI to bring all of the different data that revenue teams need. So that's everything from intelligence, revenue sources, lead sources, support platforms, really anything you can imagine that people want to bring in to help build and run their business. And we need to expose that in a way which is usable both for humans, for sales reps, as well as for agentic workloads. So what we've developed is a system that we call universal context. And what this provides is a single foundational data layer built on Spanner that brings together the kind of classic structured data that you would expect in a CRM, who owns the deal, how much it's worth, with some of the unstructured data that was previously inaccessible, so things like emails, call recordings, and product usage data. Universal context is fairly unique in the CRM space because it brings all of this information together in a way that's transactionally consistent and is available to both humans and AI agents through Boolean search, vector search, full text, all in a transactionally consistent way. And that's all thanks to Spanner. So Attio wasn't always built on Spanner. In the earliest days, we started on Postgres. And pretty early into our journey as a startup, we had the moment that every startup CEO dreams of and every startup CTO dreads, which is a very large customer, one of the big foundational AI labs, decided to sign up to our product and brought an amount of data with them that was fundamentally not of the scale that we were able to process. And so we put that data into Postgres, and the Postgres query planner promptly exploded. And we were forced to do a stressed exit from Postgres to a scale-out database solution. This was back in 2021. And at the time, we decided to partner with the Spanner team and to build out the platform on top of Spanner. We didn't anticipate that going quite as well as it did. So we moved our most intense workloads onto Spanner. And by early 2022, we'd realized this was really quite a special piece of technology. And so we began to move all of our relational workloads away from Postgres and onto Spanner. We were still, however, running full text search, and vector embeddings were not really widely spread at that point in time. And so we were using another full text solution off platform. And that's when we decided to start exploring Spanner full text search with Jeff and the team. So before we go into full text search, it's worth understanding a little bit about what makes Spanner so magical for scale. We initially turned to Spanner, like I said, because the Postgres query planner exploded. And Spanner, while it does have a query optimizer, and they're now on, I believe, version 8, the beautiful thing about it is that as a developer, you can provide it with a query plan. So this is familiar to people who may have worked with the Oracle family of databases. You can explicitly specify things like join order, join methods, parallelism, and your developers are able to premeditate the query plan that is going to best fit your workload based on information that may not be available to the optimizer. So at Attio, we're running a scale-out multi-tenant workload with tens of thousands, if not hundreds of thousands of tenants. And so query planners really struggle to make great decisions in that environment. But using query hints, we're able to force Spanner to behave in certain ways, which gives us really deterministic query planning and control over tail latencies. And finally, Spanner's global external consistency allowed us to deliver a fundamentally better platform. So things like API requests and MCP servers were seeing a transactionally consistent version of the data wherever they were running in the world. So full text search. In 2022, our full text search architecture was our Postgres primary database for our transactional workload, replicating over to a cloud service called Algolia. The basic model of Algolia is you send them a push request, and they promise that they'll index that for search at some point between now and the end of the universe. What was happening in reality was that our largest customers were experiencing quite significant materialization delays as that ETL pipeline buffers up and hotspots in various places in the search index. Today, we run a unified stack combining Spanner full-text search with Spanner vector embeddings, and we do all of that inside of the primary database, which serves the main relational workload of the platform. This is actually even more powerful than it sounds, because as Jeff mentioned earlier, Spanner full-text search is just Spanner. So it benefits from all of the availability and uptime, which is industry-leading, as well as some of Spanner's cooler, more interesting features like point-in-time reads. So if you write something to your search index and you'd like to see the search index as it existed yesterday, you're able to do that with Spanner. And here's a quick summary of the results. So for context in the crowd, we're a startup, and $165,000 is a lot of dollars on our infrastructure bill. So moving to Spanner actually was not a cost optimization originally, but Spanner text proved to be an order of magnitude cheaper than our previous search solution. In financial year 26, we realized a $165,000 gain. And for financial year 27, that renewal would have cost over $500,000. So the cost efficiency of the Spanner search solution is really quite compelling. On top of that, Spanner search also gives you a relatively obscure little parameter called enhanced search. An enhanced search uses Google's proprietary AI magic to bring your search, expand your search queries before they hit the index. So if you search cat, it will expand it to include kittens, is the kind of canonical example. This had a step change in the quality of queries that we were able to serve. We serve customers around the world in many, many different languages. An enhanced query means that even if your team works across multiple different languages, often you'll still be getting results from across those multilingual data sources. No ETL means instant search results. So this has two really important properties. The first is that we get read after write consistency. So if you are a Attio customer and you're building an API workload or an agentic workload and your agents make a change, if you then immediately make another API request, you're going to see that change reflected in the search indexes and ultimately in the vector indexes as well. So we today index 350 million documents in Spanner full-text search, growing that at a rate over 20% a month. And Spanner really doesn't blink an eyelid. And then we recently launched Ask Attio, which is our, you guys have spent the week at Next. You've heard a lot about agents. It's our agentic interface. It's our chat interface. And Ask Attio brings together all three of these modalities. So it's vector, full-text search, and Boolean search, as well as raw SQL queries, all inside of one single chat surface. And so Ask Attio builds on the Gemini embedding models, as well as the scan index support in Spanner, which gives us scale-out multi-tenant vector store, just kind of resident within our primary database. And we're using that today to serve over a billion documents and 50,000 reads a second. And once again, Spanner is handling that really, really well. Thank you very much for listening, and I hope you all have a wonderful rest of Next.
Thanks a lot, Alexander. That was a wonderful example of how Spanner powered a journey through time of scaling up your system, saving you money, and improving your overall customer user experience. That was awesome to see. I'm Girish Baliga. I'm Director of Engineering Spanner. And for the rest of the talk, let's get into the guts of it and see how all of this is put together. So there are three parts or three components to doing AI search on Spanner. So you have text-based search or full-text search. You have vector search. And you have graph. So in traditional systems, like Jeff mentioned earlier, you would probably have customized systems for each of these things, right? So you would have a database. You would have a text engine. You would have a vector engine. And you would have a graph database. And a big part of your system would be moving data around, making sure it's all consistent, all of that complexity. Spanner makes it very simple. So in Spanner, you can basically have all of this functionality by just using DDL. So you can define a text index, you can define a vector index, you can define a graph. And for the two indexes, text and vector, we'll automatically create the index for you, we'll backfill it, and we will keep it transactionally consistent. So as your data gets updated, you'll see the results instantly, like Alexander mentioned. All right, so let's go into each of these components in some detail. So for full text search, obviously this is the standard token-based search that many of you are familiar with. So you can define a tokenization of specific data in your spanner table, and we will build the inverted index and allow you to search on it. But on top of this, we have built some additional interesting capabilities. So your search can really be intelligent, right? So we have features like fuzzy search. So this allows you to search with spelling mistakes, get around different ways of spelling things. We have auto-language detection. So the system will automatically detect the query language, the document language, synonym substitution. And finally, the one hidden, well, not so hidden feature that Alexander mentioned too, which is Google-powered intelligent search with enhanced queries. So when you're doing these search results, this really scales to Google, right? So Alexander mentioned around 250 million documents. We've seen use cases with like 100+ billion rows, right? And Spanner just works. You get sub-second latencies. You won't see a latency drop-off. It just scales. So search gets you the results that you're looking for, right? You get your retrieval results. Now, how do you rank them? How do you decide which result is more interesting than the other one? So there are different ways in which Spanner allows you to rank results. So you could do text-based ranking. So you could say, find me the result that is most relevant based on the text of these documents. You could do vector-based ranking. So you could say, find me the results that my embeddings or my ML model thinks is most relevant. Or you could fuse results, right? You could do RRF. You could also extend your full text and combine it with vector and graph and have much more comprehensive results. So Jeff gave a preview of this with the demo that he did, but we'll look at some more templates later on in the talk. But first, intelligent search. So let's say you're trying to build search on a customer table, right? So you have your customer table on the top left corner there, and you have a first name column. So the first thing you would do is you would define a token list on top of this column. And then Spanner will automatically generate tokens for all the first names in your table. And then you build an index on top of this. And this is where we have the inverted index built based on this. So a couple of things you will notice here. So we are using a special tokenized algorithm here called tokenized n-grams. This is the thing that allows you to do fuzzy search, right? So n-grams, as some of you might know, is basically splitting your text into size 3 substrings, as it's specified here. And then we index those substrings. And when you do the search using this token index, we return results. So for instance, when you have a query where you're searching from customers looking for the name Jeffrey, this will match Jeffrey as well as Jeff, as you can see in the result set there. But then the ordering is default, right? So it's basically ordered based on customer ID. But suppose you want the ordering to be matching based on the query text itself. So then you could change the order by using an order by score n-grams. So not only are you searching with n-grams, you're also ordering with n-grams. And so when we do a second query here with the string Jennifer, you'll see that the results are ordered with Jennifer as the best fit, Jen as the second best fit, being a substring, and then Jenny, which is an alternate spelling. Right? So with fuzzy text search, you can basically get different spellings, different ways to represent words, and capture mistakes. But we can do better than this. So this is the secret thing that Alexander was talking about earlier. So when you have a query, you could actually go beyond just misspellings. You could go and find equivalent words in your document list. So for instance, here we have a product table where we're basically trying to search for this query term hair dye. Now, as many of you might know, not every product is going to have the exact word hair dye in it. And so what you could do for this kind of search use case is you could say enhance query true. And then Spanner will automatically take your search term hair dye and expand it. It'll rewrite it, as you can see in the bottom here. So it'll say hair expands to hair or hair dye, or other words like color, coloring, dyeing, and all these other alternative ways to capture results. Now, this is the exact same technology that we use in Google search. So if you go search for hair dye in Google, we do this exact same thing. And what Spanner search allows you is it brings this power to your product search. All right, the second component of AI search is vector search. So while in full text search, you're basically tokenizing your documents and you're in the realm of words, what vector search allows you to do is it basically takes your documents and your query strings and maps it into vectors, right? And so once you are in the domain of vectors, then what was a text match problem becomes a vector distance computation problem. And this is particularly interesting because, as you might all know, ML models, AI models, they operate in the domain of vectors. For an AI model, everything is numbers. And now, with this kind of an approach with vector search, you are able to bring the full power of your AI model and enhance your search capability significantly. So within Spanner, right now we support both KNN and ANN. And your indexes with ANN are transactionally consistent with your updates, right? So as you update your data, you'll get the most relevant results right away. And we have this other implementation, a specialized implementation of vector matching called SCAN. So this came out of Google research. This is actually a very interesting algorithm. This contrasts with the other kind of algorithms like HNSW in the industry, where you are able to tune the performance and scale based on different parameters. Now, we'll go through some examples to see how to do this, but this is something that you get out of the box with Spanner. So in addition to using embeddings, Spanner also has deep integrations into AI models and the LLM ecosystem. So you might have seen a glimpse of this in Jeff's demo, where he was basically using an LLM to generate embeddings for a query string and then match it into your vector index. But you can do this even to generate your vector embeddings. So basically, you could have an ML model sitting in Vertex or Gemini Enterprise, and then you could basically have Spanner directly call your model, generate the embeddings, and keep them up to date and build an index. It all works out of the box with DDLs. We also have integrations with LangChain and Notebook, so you can try these things out, analyze, play with them, and so forth. Again, being on Spanner, vector search is highly scalable and available. You get the same finance reliability. And we've tested this with 10 billion plus vectors. So this is going to be with you for a long time. So you will, we don't anticipate scale problems as your business grows on Spanner search. We covered hybrid search before. So basically, with vector search, a couple of interesting ways you could incorporate is you could rank your full text search results with vector search. You could combine vector and full text to get bigger corpus of results. And you could also implement extension of RAG called graph RAG. So these are things that we will get into detail in a little bit. But first, let's dig a little deeper into vector search. So at the top there, we see a table called documents that we have defined. You basically have a doc ID string and some doc contents, which are the contents of your document. And then you can use an ML model to generate the embedding for each document row, right? So that is the doc embedding row that you see, which is basically an array of floats. So with KNN search, basically what you can do is you can directly use that embedding column and filter on it. So you can basically compute the distance of a query embedding with the document embedding and get the results directly. So if you have a small corpus, or if you are combining your vector search with some other filters, so for instance, when Gmail searches all the mails for an individual user, that's a small result set, right? And so in those cases, KNN works great. It works well for small corpuses, highly filtered result sets, and partitioned queries. But when you want to scale, when basically vector search is your primary search mechanism, right? This is where it becomes really expensive to compute your embedding distance from query embedding distance from all the documents. And this is where approximate nearest neighbor comes in. So basically what you're doing is instead of looking at every single row, you're building an index. And what this index does is it takes all the vectors in your document set, and then it clusters them, as you can see at the bottom here, right? So you find basically clusters of documents which are close together. And then you represent each of these clusters with one representative. It could be the centroid, right? So the one which is equidistant to all the documents in your cluster. So basically, we build a tree using this structure. And so this is built and maintained automatically. So the second statement you see there, create vector index, that builds this index. It computes these clusters and builds the tree. And you see there distance type cosine. So we support 3 different distance types in vector index, cosine being one of them. And so when you are building this index, it will use the cosine distance between the documents to cluster and figure out what is the tree structure. So when you're actually doing your search, which is the bottom select statement right there, so what you can do is you basically say, OK, find me all the documents that correspond to this search term MLB. So we compute the embedding for MLB, and then use our index to figure out what are the best matches, right? And basically, it will use the Euclidean distance in this case to traverse the index, find the most relevant clusters, and do a localized search. So essentially, what you can see here is you're trading off a little bit of precision by, say, not looking at all the documents, but just a subset. But then this becomes much faster and much cheaper because you're basically guiding your search very well. So here are some new search features we are launching or announcing today. So Spanner, both full text and vector search, have been in production GA for over a year. And so these mark major new milestones in both the products. So for full text search, we are announcing GA of custom dictionaries. So this was a very heavily requested feature. So the enhanced query that we told you about, basically using the Google secret sauce, that works well in general query settings. But when you have a specialized domain, right? So if you have, for instance, retail search or some very specialized e-commerce domain, then we've seen customers have their own specialized lists of mappings to query terms. And so custom dictionaries allows you to plug it in, and Spanner Search will incorporate that in the results. We also have some significant improvements in vector search latency. So if you've tried vector search maybe 6 months ago, I would encourage you guys to go try it right now. You'll be surprised. It is much faster. And lastly, we've also made some significant improvements in usability. So your index will build faster. Small indexes build in minutes now, maybe even sub-minute. Large indexes build faster than pretty much any other system out there. And we also have some major improvements in hybrid search. So let's jump into some of these hybrid search templates now. So there are different ways in which you can combine text with vector. So here is a simple way, right? So you have a table called products, and you have this query term, space themed Lego for 8+. So the full text search is basically looking at all your items, going through the index and finding documents that match. So it's basic token-based matching, right? So you get your text matches in the middle. And then instead of using a document-based ranking, you can use a vector search-based ranking. So you can basically use embeddings for these documents and use the Euclidean distance to compute your elements. So this is very cool. Like if you want to do this outside of Spanner with custom systems, this would be in your application logic. In Spanner, this is just a where condition in your SQL query. It's like a file-line query string. Like this thing is a whole search stack, if you're looking at it. So another more interesting example. Let's say you did your search, and your search gives you precise results, but it doesn't give you enough results, right? So your space theme toys are not matching, let's say, Star Trek toys or some other thing, and your query expansion doesn't do the trick. Then what you can do is you can use vector search. So you can use two retrievers here. So you have a full text retriever, which gives you your space-themed products, and then your vector search retriever, which could do things like Star Trek, Star Wars, things like this, which don't naturally have the space theme in their name. And then you could merge the results of both of these retrievals using multiple techniques. So this example here uses RRF as a technique to merge these. We also support relative score function. You can also do re-ranking and merging using ML models. So all of these are very well documented. You can go to the Spanner search documentation and take a look. But this is usually what people do when they do hybrid. They have multiple retrievers and some re-ranking logic to figure out how to merge the results. Finally, graph. I hope many of you had a chance to go listen to our Spanner graph talk earlier in the day. If you haven't, I would urge you to go check it out later. So Spanner has this really nice implementation of graph, right? So the way we do graph in Spanner is you have your relational data, and graph is defined as an overlay. So instead of having a copy of your data and building a graph, we basically allow you to define your graph right there on your relational table data. And so what this allows us to do is now it becomes very easy to combine your full text and vector with your graph. So for the example in the top, a very common problem when you're doing graph-based usage is you want to do some sort of a traversal, right? So you want to start with a node, and then you want to traverse and see what are the other linked nodes to that node. But how do you find the node you want to look for? So typically, people use some sort of a secondary index, right? Exact match or something. But you can use a full text index. So you can use a full text search to find your starting node, rank it, get the most relevant, let's say 10 nodes, and then do your retrieval. Again, a simple search query to do the SQL, right? It's all in SQL. Another very interesting use case is RAG. So in traditional RAG, what you would do is you basically have an embedding set, and then your LLM basically generates its embedding and then looks at the database, the vector database, and finds the most relevant documents based on the embedding vector search-based match, right? So that's your traditional RAG. The problem with this kind of approach is it's relying on the model's understanding of the relationships in your data. So the ML model that generates your embedding needs to understand the relationships in your data. And so you're going through that bottleneck, the ML model bottleneck, to model what you already know about your data and try to teach the ML model how to encode it in embeddings, and then try to pull it out of the other end with your RAG query. So with graph, what you can do is you can actually model the relationships directly in your data as a knowledge graph, right? So if, for instance, you know that a set of documents are connected and they're basically describing one particular product or one particular feature or something, you could link them all together. And then when you're doing your RAG with graph, what we call graph RAG, then you can start with your vector search. You can figure out the most relevant starting points, and then you can expand the context based on these relationships that you have defined in your graph. And in practice, with multiple customers, we found that graph RAG significantly outperforms RAG in terms of performance and recall and precision and quality of results, right? And so just the way in which we have incorporated all of these three components of AI search, full text, vector, and graph, allows you to build an entire end-to-end search engine search stack just with a single SQL query, right? That's the magic of having it all in one system. So to bring it all together, AI search has three main components, right? Full text, vector, and graph. Spanner allows you to define all of these in your operational database directly. And you are able to build extremely complicated search strategies directly on top of Spanner just using SQL. And you get all the benefits of SQL. You get the scale, you get the availability, you get the reliability. So here are some other talks that we have on Spanner. We basically, I think most of these have completed, but there is a very interesting one tomorrow if you're interested, where we are going to talk about some new analytics capabilities that we've just added to Spanner. It's a very cool talk. I would really urge you to check it out if you're interested in analytics use cases and general conversational analytics on top of an operational database. So building search on Spanner has been an amazing journey for us. And it's really great to see stories like Alexander's and Attio, where they were able to build these really interesting and cool features on top of Spanner Search. I shared some recipes with you on how to combine some of these components together, but we really want to see how you guys take this and build amazing things in all of your products. So with that, thank you all for your time. And I think we can take a question and maybe continue the conversation later.
I didn't think we had that much content.
Questions?
Tell them we can talk in the hallway.
Yeah. So if you're feeling a little shy, please come find us. We'll be in the Oh, there's a question. Please go ahead.
Yeah. So are all the features that you demoed are also available in Spanner Omni?
Yes, absolutely. So everything we showed here is available in Spanner Omni. Spanner Omni is basically a copy of whatever we have running in our managed service. So there will be some things that will work a little differently. So for instance, the enhanced search feature requires integrating with our keyword expansion service within Google. So some features like that might not work. But all these SQL features that I said, the index building, the algorithms around mapping and matching vectors, so all of that works, just as I described it. Other questions?
Does Spanner also index using like an HNSW kind of methodology, or is it purely?
So right now, we mainly have scan, which is the clustering mechanism I told you about. Mm-hmm. I think we have some plans to take up HNSW, but we should talk offline. Yes, this is something that we are exploring as well.
Thank you.
Yeah. All right, thank you all for your time. It was a pleasure sharing Spanner Search and some of our awesome stuff with you. Let's continue the conversation in the hallway. Hope you all have a wonderful rest of your Google Next. Thank you.